Hello and welcome. My name is Dan Johnson and thank you for stopping by the SFI Compliance channel. We're proud to announce a new series of safety videos designed for the construction industry for our workers and employers. So if that's you, great. Don't go anywhere. We've got a great episode for you today.
Each year, about 1,000 workers lose their life in the construction industry. On average, roughly 300 of those workplace fatalities happen from falls to lower levels. These fall fatalities were and are preventable. Today, we're going to talk about the ABCs of fall protection. But before we do, there's a couple of things we should address beforehand, and 3 words that are key to this topic. The first word is plan. It is vital that you plan ahead to get the job done safely. When working from heights, employers must plan projects to ensure the job is done safely. Begin by deciding how the job will be done, what tasks will be involved, and what safety equipment may be needed to complete each task. When estimating the cost of a job, employers should include safety equipment and plan to have all the necessary equipment and tools available at the construction site. For example, in a roofing job, think about all the different fall hazards, such as holes or skylights and leading edges. Then plan and select fall protection suitable to that work, such as a personal fall arrest system or PFAS. The next word is provide. It is essential to provide the right equipment. Workers who are 6 feet or more above lower levels are at risk for serious injury or death if they should fall. To protect these workers, employers must provide fall protection and the right equipment for the job, including the right kinds of ladders, scaffolds, and safety gear. Use the right ladder or scaffold to get the job done safely. Some work requires workers to use personal fall arrest systems or PFAS. Make sure to provide a harness for each worker who needs to tie off to the anchor. Make sure the PFAS fits and regularly inspect it for safe use.
All right, guys, we're going to talk about fall protection today. We're going to talk about the ABCs.
The final of our 3 key words is train. Train everyone to use the equipment safely. Every worker should be trained on proper setup and safe use of equipment they use on the job. Employers must train workers in recognizing hazards on the job. See educational materials and resource page for posters, fact sheets, and other training materials. Now that we've got that down, let's move on. A personal fall arrest system, or PFAS, is comprised of 3 vital components: an anchorage, full body harness, and a connecting device such as a shock absorbing lanyard or self-retracting lifeline. The safety of at-height workers depends on these 3 components, and each one must be in place and used properly to provide maximum worker protection. When discussing fall protection, anchorage points and full body harnesses receive a lot of attention. We don't always stop to think about connecting devices, such as self-retracting lifelines or shock-absorbing lanyards, and yet these are the components that bear the greatest forces during a fall. Before we discuss the importance of the connecting device, let's review the definition of each PFAS component as defined by OSHA and ANSI. According to OSHA, fall protection is required if any risk exists that a worker may fall from an elevated position. Fall protection itself is required anytime a worker reaches a height of 6 feet or more in construction. To determine your working height, measure the distance from the walking working surface to a lower level or to the ground below. As we discussed above, OSHA mandates the use of a full body harness with a shock absorbing lanyard or retractable lifeline as part of the complete PFAS. A full body harness, for instance, distributes the forces throughout the body, and a shock absorbing lanyard decreases the total fall arresting forces. Let's look at each of these components briefly before diving deeper into the importance and specifications of connecting devices such as shock absorbing lanyards and self-retracting lifelines. An anchorage is commonly referred to as a tie-off point, such as an I-beam, rebar, structure, or rigid track system. An anchorage is quite literally a secure point of attachment for your lifeline or lanyard that is independent from the worker's means of support and suspension. An anchorage connector, on the other hand, is the component used to join the connecting device, such as a shock-absorbing lanyard or self-retracting lifeline, to the anchorage. Anchorages must be placed high enough for a worker to avoid contact with a lower level should a fall occur, and they should be able to support 5,000 pounds of force per worker or maintain a safety factor of at least 2 under the supervision of a qualified person. Anchorage connectors must be positioned so that the workers won't endure a swing fall hazard in the event of a fall from height. A full body harness is the personal protective equipment worn by a worker at height. A full body harness is the only acceptable form of harness to be used for fall arrest applications. That's because a full body harness distributes the fall arrest forces across the shoulders, thighs, and pelvis. They also have a center back fall arrest attachment to connect to the fall arrest connecting device, and may even include additional D-rings for use in worker positioning, fall prevention, or suspension. Full body harnesses must meet the requirements of ANSI ASSE Z359.1 for fall arrest applications. This means that any work positioning or travel restraint attachments, such as D-rings, must withstand a dynamic strength test of a 3.3-foot free fall using a 220-pound test weight. Additionally, the dorsal or back D-ring must be suitable for rescue applications unless otherwise prohibited by the manufacturer. Other rescue attachments must meet the 3,600-pound static load test criteria along with the dynamic test criteria of a 2-foot free fall distance, also using a 220-pound test weight. Connecting devices are a crucial component of a complete PFAS. The connecting subsystem is the critical link that joins the full body harness to the anchorage and anchorage connector. Connecting devices can consist of shock-absorbing lanyards, self-retracting lifelines, rope grabs, or retrieval systems. How the connection is made depends on whether the worker is equipped for personal fall arrest or work positioning. For the sake of this discussion, we are only focusing on personal fall arrest components. The connecting means for a PFAS is usually either a shock-absorbing lanyard or self-retracting lifeline. A lanyard is defined as a flexible line securing a full-body harness to an anchorage point. Shock-absorbing lanyards reduce the energy transmitted to the user's body in the event of a fall. Shock-absorbing lanyards also decelerate during the fall. This reduces the fall arresting forces on the worker by approximately 60 to 80% below the threshold of an injury, as specified by OSHA and ANSI. OSHA mandates that all lanyards include double action, self-closing, self-locking snap hooks to reduce the possibility of rollout during a fall event. Shock absorber pack can also be built into non-shock absorbing lanyards to provide shock absorbing capabilities. The inner core of a shock absorbing pack expands smoothly to reduce fall arrest forces during a fall. Self-retracting lifelines, or SRLs, are another viable option for connecting devices depending on your application and fall protection needs. Self-retracting lifelines reduce the free fall distance and energy loads from a fall. SRLs also enable greater horizontal and vertical mobility than a standard 6-foot shock-absorbing lanyard. There are great benefits to using SRLs, including shorter activation and arresting distances, which reduce the risk of workers impacting the ground or lower level below. While standard shock-absorbing lanyards allow for up to 6 foot of free fall distance before activating, self-retracting lifelines require less than 2 feet to arrest free falls. According to OSHA 1926.502d, horizontal lifelines must be designed with a minimum braking strength of 5,000 pounds. Similarly, self-retracting lifelines and lanyards that do not limit the free fall distance to 2 feet or less must be capable of sustaining a minimal tensile load of 5,000 pounds when fully extended. However, self-retracting lifelines that automatically limit the free fall distance to 2 feet or less must only be capable of sustaining a minimum tensile load of 3,000 pounds when fully extended. Connecting devices offer many options, and they should be considered based on the application at hand and working environment. It's always smart to use a lanyard or lifeline attached to an anchorage point that is positioned directly overhead to protect workers from swing fall. Although all 3 components of a PFAS are subject to the total fall force, connecting devices are comprised of only one strength member, such as webbing, rope, steel cable, etc. It's essential to choose a connecting device that is high quality and to check it daily for excessive exposure to UV light, chemicals, physical damage, and/or improper storage. inadequate inspection can easily lead to device failure. Consider the following when selecting the right type of connecting device for your specific personal fall arrest needs. Application and environmental conditions. This includes the presence of moisture, dirt, grease, oil, acids, hazards and obstructions, and ambient temperature. Potential fall distance. Your potential fall distance is usually greater than anticipated. It's important to consider the length of your connecting device along with the length of elongation during deceleration, worker height, and an added safety factor. System component compatibility. It's crucial to design test your PFAS as a complete system because components from multiple manufacturers may not be compatible with one another. Incompatible or non-interchangeable components can easily cause rollout. Product quality and regulations. Don't skimp on your PFAS components. The better the quality, the safer the worker. Furthermore, although OSHA regulations are enforced by a federal agency, ANSI standards are suggestive and self-enforced. Even so, ANSI standards should not be taken for granted. Use ANSI standards alongside OSHA regulations as part of a stated performance indicator. ANSI standards are written to save lives and prevent worker injury and should not be taken lightly.
Now that you learned about the ABCs of fall protection, it's very important that you protect yourself. OSHA requires that you rig your fall protection so you free fall no more than 6 feet. However, it's best to rig your fall protection so you don't free fall at all. If you do free fall, your body will experience a force like this. Tune in next time for episode 2 in our safety video series.